Okay, so guys, in this video we are going to discuss linear approximation. Now tell me one thing, if we have a number 2.99 power 4 and I ask you to find the value of it without using the calculator, of course, so most of you won't be able to do it because we know that 3 power 4 is 81, but what is 2.99 power 4? This is where the linear approximation comes into the play, and it tells you that it is basically a method by which you can approximate the value of any function given to you. Okay, so it is basically an approximation of a function using the linear function. So you basically convert that given equation into the linear equation into a linear function, and then you can approximate the value of that unknown function. And I will explain that using an example. So 2.99 power 4, and you have to calculate its value. Basically you have to approximate its value. Now we know that 2.99 we cannot calculate it, okay, without a calculator. So let's say that this is my x and x is unknown. We are unable to find the value of x power 4. So f of x will be x power 4, and we can do one thing, that we can say that suppose x1 is 3. Why specifically 3? Because 3 is the number closest to 2.99 for which we can calculate the value. If you remember, we have the point slope form. So point slope form actually says y minus y1 is m x minus x1. So m is basically the slope, x1 is x1 right over here, and y1 is the value of the function at x. So y1 is basically f of x1. So x1 will be x1 power 4. This is the same thing which is the value of x1, and y we know already that it is basically a dependent variable which is dependent upon x, which is an independent variable. We have supposed x1, which means that we know x1, and based upon that value of x1 we can calculate the value of y, which will be the value of that function. Okay, so x1 is actually 3, power 4 will be 81. So we know y1, we know x1. Now how can we calculate the slope? So the slope is basically rise over run. The slope will actually be the first derivative of this function right over here. Okay, so it will be the first derivative. Now it is this notion about slope being the first derivative of x basically only for this linear approximation method. Otherwise the value of slope is actually rise over run, but over here it is the first derivative of x. So the first derivative of x will be 4x3, and the x which we have supposed is 3. So 3 multiplied by 3 cube will be 108. So this is the value of slope. So now let's put all of these values into this equation. Y minus y1 is 81, m i.e. slope is 108, x minus x1 is 3. So now we can basically derive an equation for y. So y will be equal to 108 x minus 3. This 81 will be moved toward the opposite side. We will have 81 with a positive sign. Now I won't recommend you to simplify this thing, because we will actually put the value of the original x over here. So this is basically known as the tangential equation, the tangent line equation or the tangential equation, and this will actually tell me the approximate value of my function 2.99. So let's put x 2.99. So y is basically the approximation of this function. So 2.99 minus 3 plus 81, negative 1.08 plus 81, this will be 79.92, which is actually the value of 2.99 power 4. Don't you see, it is actually very near to 3 power 4, which is 81. 2.99 power 4 is 79.92. Okay, let's try one more example. Okay, so guys, in this example we have to find the value of square root 9.1. Now all of us obviously knows that this value of square root 9 is 3. Now how can we approximate the value of square root 9.1? Remember the 3 steps of solving this question. First of all, you have to suppose a function for which the value of x is known. For our case it will be 9. Then you have to find the value of y at that specific point by putting it into the function. Then you have to find the value of the slope, you will get the tangential equation. You have to put the original function x into that equation and you will find the approximate value of it. Okay, just the things which we have done in the previous example. So let's do these things. First of all, this is my x which is unknown. I can say that suppose x1, which will be known, which is actually a very definite value, it will be 9. So fx over here will be square root 9.1, which will be square root x. F at x1 will be square root 9. So our x1 is actually 9 and we just placed it into the original function. So it will be 3. So now this will be my y. So x1 is 9 and for the value of x1 9, the value of y1 is 3. Then we have to find the value of the slope. The slope for our relation would be the first derivative of x. x1 will be square root x1. Okay, so d by dx. So we have d by dx x1 on by 2. So let's just use the power rule. So we have 1 divided by 2 square root x. This will be the derivative, the first derivative of x1. So 1 divided by 2, value of x1 is 9. We have 1 divided by 2 multiplied by 3, which will be 1 divided by 6. So this is the value of the slope. Now let's put all of these things into the point slope form. Y minus y1 is equal to m x minus x1. So y minus, the value of y1 is 3. Value of slope is 1 by 6. X minus, the value of x1 is 9. So let's derive an equation for y. So we have 3 will move towards the opposite sign. It will become positive 3 plus 1 divided by 6 x minus 9. Now this thing right over here will be my, and this can be used to approximate the value of original function 9.1. Okay, put x is equal to 9.1. So y is equal to 3 plus 1 divided by 6, 9.1 minus 9. So 3 plus 1 divided by 6, 9.1 minus 9 will be 0.1. And if we just do all of these things, we will have, so this is actually 3.01, and which actually makes sense because square root 9 is 3 and square root 9.1 is 3.01. Okay, so we have just approximated the value of square root 9.1. Let's try one more example, and I hope you will be getting much more feasible while adopting this method. Okay, ln 1.1, you have to basically approximate the value of ln 1.1. I would like you to try this question on your own first of all, and then let's solve this thing together. Okay, so the first question that comes to your mind is what will be the approximate value which we will be taking. Log of 1, natural log of 1 is basically equal to 0. So this is the definite value which all the entire world knows, and we can use it for our approximation of natural log of 1.1. Okay, first of all, we'll say that this thing is x. So the function becomes natural log of x. Now let's suppose x1 will be 1. So then the function at x1 will be, of course, natural log of 1. And this will be my y. So at x1, y1 is, natural log of 1 is 0. Now let's find the slope, the first derivative of x. So the slope will be the first derivative of x, the first derivative of natural log of x1. Okay, so the derivative of natural log of x, it will be 1 divided by x1, and x1 is actually 1. So 1 divided by 1 will be 1. Now let's put all of these things into the point slope form. Y minus y1 is 0, m is 1, x minus x1 is 1. So y will be equal to 1, x minus 1, and now this is my tangential equation which we can use to approximate the value of 1.1, natural log of 1.1 actually. Okay, so put x is 1.1, so y will approximately be equal to 1.1 minus 1, y will approximately be equal to 0.1. And again, this makes sense because natural log of 1 is 0 and natural log of 1.1 is just 0.1. Okay, now let's approximate the value of square root of 17. Okay, so the first thing that comes to your mind is what will be my approximate value. Okay, so we know that square root 16 is the nearest number to 17, which is a perfect square of 4. So we can use this notion to approximate the value of square root 17. So first of all, this would be my x. So f of x will be square root of x will be square root of 17. So let's just suppose x1 is 16. So f at x1 will be square root of x1, which will be square root 16, which will be of course 4. So y1 is 4. So at x1 16, y1 is actually 4. We can calculate the value of slope, which is the first derivative of x. So the first derivative of x will be derivative of x power 1 by 2, which will be 1 divided by 2 square root x 1. 1 divided by 2, x1 is actually 16, which will be 1 divided by 2 times 4, which will be 1 divided by 8. Now we can put all of these things into the point slope form. So y minus y1 is actually 4, slope is 1.1 upon 8, x minus x1 is actually 16. So we can move this 4, so y is equal to 4 plus 1 divided by 8 x minus 16. When the 4 moves toward the opposite side of the equation, it will become positive. So this is my tangential equation, and now we can put x as 17 to approximate the value of square root 17. Y will be the y is actually the approximate value of 17. So 4 plus 1 divided by 18, 17 minus 16, which will be 4 plus 1 divided by 18, 1. So the approximate value is 4.055, which again makes sense because square root 16 is 4 and square root 17 will be something higher than 4, so it will be 4.055. Okay. And the last example of the day is to approximate the value of sine 46. Now I would like you to try this question on your own. Now the first things first, what will be my approximate value? What is the definite value closest to 46, which has a whole number, which has a value known to all of us? Of course, it is the value of sine at 45 degrees. So the value of sine at 45 degrees, all of us know that it is square root 2 divided by 2, which is 0.701. We can use this notion to approximate the value of sine 46. First of all, this will be my x as a supposition. So we can say that the function at x will be sine of x, and the value of x for now is sine 46. Now let's just suppose that x1 is 45, because that is the only value which we know. So then the function will become, at x1, the function will be sine of x1, which will be sine of 45, which will be 0.7071. And this is actually the value of y. So the value of x1 is 45. The value of y1 will be 0.7071. So let's find the value of slope, the first derivative of x1. So the first derivative of x1 will be sine x1, the derivative of sine x1. So the derivative of sine x1 is actually cos x1. So the cos, what is the value of x1? It is 45 degree. So cos 45 degree is again square root 2 divided by 2. Now we can put these things into the point slope form. Y minus, the value of y1 is 0.7071. Value of slope is again 0.7071. X minus, the value of x1 is 45 degrees. Remember, this degree is actually very important. You will come to know this why. So we can just move this 0.7071 towards the opposite side of the equation. We have positive 0.7071 plus 0.7071 x minus 45 degrees. Okay, now this will be my tangential equation, and now let's put the value of x as 46 degrees. So y is equal to 0.7071 plus 0.7071. X is 46 degrees minus 45 degrees. So 0.7071. Now 46 minus 45 will be 1 degree. 0.7071. Now remember, it is saying 1 degree. We already know that in trigonometry we cannot deal degree as it is. We have to convert it into radians. So 1 degree into radians will be 1 multiplied by pi by 180, which will be 0.0174. Okay, so we have 0.7071 plus 0.7071 multiplied by 0.0174, which is actually the value of 1 degree in radians. So this is 0.719, which again makes sense because sine 45 is 0.7071 and sine 46 degrees is 0.719. Okay, so I hope you understand the linear approximation theorem.